This video is a review for the Edgenuity lesson, solving equations using properties of logarithms. So one thing that they didn't really talk about a whole lot in the video is how this works. So just as a reminder, logarithms and exponential functions are inverses of each other, meaning when we're solving, they would undo each other. Just like adding undoes subtraction and multiplying and dividing go together. And if you have something squared and you wanted to undo the squared, you'd square root. So when you have log base 5, an exponential function, 5 to the power of x, these are inverses of each other. The key to note is this base number here and this base number in the exponential function have to match. They have to be the same for this to work. So looking at the first one, if I have log base 3 of x plus 1 equals 2, and I want to solve this, I can't get to the x until I've undone log base 3. So what we use is a big 3. And essentially what we're doing is we're taking a 3 and then putting this in the exponent. Equals 3, and now our exponent is a 2 squared. So when that happens, the 3 to the power of log base 3 actually cancels out, and we get just x plus 1 equals 3 squared, which is 9. And we just subtract 1 from both sides. Now you always need to make sure that you don't get an extraneous solution. You can't take logs of negative numbers. So if you ever plug it back in and this becomes negative, then it's an extraneous solution. This one is not, it would be 9. So on this one here, we have 4 to the power of log base 4 of x plus 8 equals 4 squared. So over here, 4 to the power of log base 4, that cancels. They're inverses of each other. So then we just have x plus 8 equals 16. Subtract 8 from both sides, x is 8. If I were to plug that back in, that's going to be a positive 16, so we're good. Now, if I wanted to solve this here, I can't jump straight to using an exponential function because we have 2 separate logs and you have to put them together. There can only be one log on either side. You can't have any addition or subtraction of logs. So if you recall from the last lesson, if I wanted to rewrite this as one log, subtraction goes with division. So I would change it to 9x divided by 3, which I can simplify. 9x divided by 3 is 3x. So now to undo this base 2, I'm going to use an exponential function of 2. So 2 to the power of log base 2 of 3x equals 2 to the power of 3, or 2 cubed. So 2 log base 2 cancels, and we get 3x equals 8. Divide both sides by 3, and we'll just leave that as 8/3 for now. Okay, last one. Log 5x plus log x minus 1 equals 2. So remember when there's no number here, it's called the common log, and there's an imaginary 10. So I'm going to put those together, because we can only have one log when we're solving this. Addition goes with multiplication. So I'm going to distribute this to both parts. So we end up with log 5x squared, I guess I could put parentheses, minus 5x equals 2. All right, so now we have to, like I said, we have to get rid of this log, which is an imaginary base 10 here. So we're going to do 10 to the power of log 5x squared minus 5x, and then 10 to the power of 2, or 10 squared. These cancel, and we get 5x squared minus 5x equals 10 squared, which is 100. Whenever you have an x squared and an x in an equation, you have to factor. So I have to get everything on one side. And factor it. So what you have to do is, since this is an equation and there's an equal sign, as long as you do the same thing to both sides of the equation, it stays balanced. So everything on this left-hand side is divisible by 5. So I'm just going to divide both sides by 5. So you have to do to all 3 of those parts. So 5x squared divided by 5 is just x squared. Minus 5x divided by 5 gives us a negative x. And then negative 100 divided by 5 is negative 20. Okay, now, oh, and then 0 divided by 5 is still 0. So now we have no number in front of our x squared, so we just have to decide what two numbers multiply to negative 20 and add to negative 1. That would be negative 5 and positive 4. And it's still equal to 0, so our very final step is we have to set each of these equal to 0 and solve. So add 5 to both sides, subtract 4 from both sides. Always check for extraneous solutions. So if I plug 5 back in, okay, that's going to be 25. That's going to be 4. Perfect, no negatives. If we plug negative 4 in, though, this is going to be negative 20. So already I know that's an extraneous solution. You can't do logs of negatives.